Every day, around 1,000 new residents move to Florida. The population increase causes development that places strain on our already fragile ecosystems. With no end in sight to current immigration patterns, there's a dire need to protect our conserved land. We must find a way to balance infrastructure for humans and native species for wildlife. By tackling this one trail at a time, there is an opportunity to increase conservation lands around the Florida Wildlife Corridor through nature-based recreation. I am Megan Laffey, and this project acts as a guide to do so. The Florida Wildlife Corridor is a statewide network of 18 million acres supporting both wildlife and people. Your favorite beaches or local trails could easily be a part of it. It also supports some of your favorite species. It supports 69 imperiled plant species and 131 imperiled animal species, such as the Florida black bear and the Florida panther. These species require stable ecosystems for their survival. Unfortunately, only about half of the Florida Wildlife Corridor is protected from land use changes. The other 45% is unprotected and threatened with the spreading development that is a consequence of increasing populations, which, as you can see, are only projected to rise by 2040 and by 2070. With the increase in population, there's an increase in the use of recreation areas. While we do want people to connect more to nature, human presence can have a negative impact on trails. Trail construction, the presence of domesticated animals, litter, noise pollution, habitat fragmentation, and informal trail development all place strain on local wildlife. We must find a way to fulfill human needs, as well as those of native species, with the limited conservation funding we have available. The solution is through the concept of co-location of nature-based recreation areas and conservation lands. Co-location works to create spaces that perform natural ecosystem functions for native species while providing outdoor recreation opportunities for humans. To determine sites across Florida suitable for co-location, ArcGIS makes it possible to consider the necessary criteria. For this process, we look at priority conservation lands, existing conservation lands, and recreation opportunities. Those shown on the screen are considered priorities for conservation as they provide ecological connectivity. Layering on existing conservation lands helps to see which of those priorities will create the most connection between conservation areas. By considering trail systems, we can see the gaps that overlap with these priority lands around the conservation areas. The Florida National Scenic Trail is the focus for this project, as it is one of 11 national scenic trails and can act as a precedent for both day and through hiking trails. With this information and a little bit of calculation from ArcGIS, we can locate the ideal co-location sites, those around current conserved lands, within priority conservation lands, and around current trail gaps. But due to time constraints, this is a limited co-location analysis. There is a larger network of layers and information that can be added for more specific results, some of which are shown below here. With the results of this analysis allow us to pick a site. In this case, we're looking at Atonia Creek Spur of the Florida National Scenic Trail, which is located in Putnam County, about 45 minutes east of Gainesville and adjacent to the current Atonia Creek Wildlife Management Area. The trail is underutilized and adjacent to highly exposed coniferous plantations, which provides opportunity to redesign for co-location and ecosystem restoration. This site can provide guidance for evaluating the feasibility of future sites and demonstrate the human impact mitigation strategies to restore the ecosystem so that species such as those on the right side of the screen may be supported. In addition to the criteria detailed in ArcGIS, it's also important to look at ecosystem composition and parcel division when selecting sites from the larger analysis. As you can see, the light and dark green areas show the sandhill and mesic flatwoods ecosystem that are being encroached upon a medium green tone coniferous plantations. The limited fragmentation by urban land use offers opportunity for restoration. As for the parcels, limited parcel ownership is ideal for ease of acquisition. But to complete co-location design for a site, it's crucial to understand its current conditions. We can see that the Atonia Creek site currently is made up of two primary ecosystems, the mixed hardwoods and the mesic flatwoods with the transition zone in between. Once you first enter along a utility corridor, which also acts as a constraint to the southern edge along the site for further buffer expansion. As you hike along, overlooks exist to your right, and while the left is consistently exposed to the neighboring plantations, creating a constant human presence. As we move into the transition zone, we start to pass this reindeer lichen, which is a sensitive species that signals sensitive ecosystems. As you near the end, we again experience a shift in microclimate due to exposure to the coniferous plantations on each side, providing opportunity for increased restoration. The Mesic Flatwoods area includes saw palmetto buffers that exist as native habitat for species and also discourage people from traveling off trails. Small bridges allow people to traverse over wet soil but aren't in ideal condition. To transform the site into a functioning ecosystem with limited human disturbance, we must consider the trail route effectiveness. We should look at the slope, floodplains, and soil sensitivity to understand the entire sensitivity of the site. Compiling these factors creates the environmental sensitivity analysis, which reveals that the current trail route is currently in the most sensitive area of the site. This provides the rationale for moving the trail route along the southern edge of the site closer to the utility corridor. Before human impact mitigation strategies can be implemented on the site, the ecosystem restoration must occur. The two ecosystems undergo similar restoration processes. We begin by preparing the ground through mechanical methods, eventually taking inventory of the existing seed bank, hand planting native tree saplings, and then finally seeding for the understory below. Planting of young trees should occur at randomized patterns to mimic that of natural patterns, but it should never be closer than 15 feet in planting distance. But through this process, we can expect to see a full regrowth of the forest after about 60 years. The northwest section will return to mixed hardwoods, and the southeast will return to mesic flatwoods. And while each may not be a mature ecosystem for about 60 years, they could still be utilized by species as they grow. But after the restoration has begun, we can finally begin to implement human impact mitigation strategies. The containment of visitors along the relocated trail is imperative to preserving this core habitat that we create through reforestation. As you can see here, programming must lie along the trail, preserving that core habitat that acts as a corridor from some southern pine plantations that are adjacent to this area to the northern Atonia Creek Wildlife Management Area, which wraps around in the southern and northwestern areas of the site. This buffer is about 1,000 meters across, is determined to provide enough core habitat for some smaller native range species, such as the Florida black bear and the gopher tortoise. The other component to co-location, besides the creation of this greater core habitat, is intentional design to mitigate human impact. While there's a variety of strategies, this example focuses on general structures that can be adjusted for application to other sites across the state. First implemented is an observation deck overlooking Atonia Creek. Overlooks provide visitors with an experience like that of a great horned owl looking over the ecosystem below. The deck sits just off the ground to allow small wildlife to traverse beneath, and its connected side panelings help to contain loose litter, prevent wildlife from getting stuck, and offer a canvas for creative details to highlight features of the native wildlife. Next, large signs double as informational tools and also boundaries, keeping visitors on path, and the large height helps to create an immersive experience. The angle top helps to reverberate sound back onto trail to decrease noise pollution in the surrounding area. Sign contents can vary depending on where the signs are located, and sensory elements can be included to encourage interaction. The signs and the planting buffer behind it help to create a safer habitat and corridor for species such as the gopher tortoise or other terrestrial species to coexist with visitors. To cross Atonia Creek, a minimalistic bridge is needed to prevent bank erosion. The suggested design is a single log stringer bridge with mesh siding. The simplicity blends into the aesthetics of the surrounding forest, and the mesh helps to contain people and loose debris. In addition to creek bank preservation, the bridge also allows a unique perspective like the overlook, allowing visitors to view the river otters and aquatic ecosystem below. The simplest and most widely applicable intervention is the placement of ground fencing. The design is created from split wood logs stacked at 120-degree angles with an option for rebar reinforcement. The height and length are easily adjustable to each site. It reinforces the trail edge for visitors, especially in sensitive ecosystems, but allows unrestricted movement of roaming species such as the Florida black bear. The final intervention listed is a planting buffer. 100 feet wide planting buffers have the ability to decrease noise pollution by up to 8 decibels. Buffers shorter than this can still offer sound mitigation, especially when planted densely with evergreen species such as the sawfall meadows. Buffers should utilize both overstory and understory plants native to the target ecosystem, hence the options listed for mixed hardwoods and mesic flatwoods. Planted buffers help to strengthen ecosystem restoration and aesthetics along the trail to develop experiences for visitors and also habitat for wildlife. This case study and implementation of design at Atonia Creek Spur can serve as a guide for future sites. Should the land be properly restored, it would add 1,500 acres to the nearby Atonia Creek Wildlife Management Area and overall Greater Florida Wildlife Corridor. And while this number may not seem that large compared to the overall acreage of the corridor, the completion of all of these sites would add 99,000 acres to the Florida Wildlife Corridor and 116 miles of co-location-specific trail to the Florida National Scenic Trail. By taking a wildlife-first approach, we can create stable ecosystems where we can add recreation opportunities onto the periphery. Co-location has the potential to drive conservation efforts through human-nature connectedness, maximizing funds, and providing space for all of Florida's species. All the information included in this presentation and more is detailed in One Trail at a Time, a guidebook for co-location. It provides a step-by-step ArcGIS process, design considerations, and interventions through the Atonia Creek case study site. It should be used for planning the design and development of similar sites to inspire larger entities to continue the work that we've begun in Florida, creating a world of coexistence. I would like to thank my partners at the Center for Landscape Conservation Planning at the University of Florida and the Florida Wildlife Corridor, as well as anyone else who helped along the way. Finally, I would like to share this photo from my site visit. I looked down after returning from my hike to see that a river otter had crossed over my tracks. This is truly the beginning of creating a place for all. Thank you so much.